Hello everyone and welcome to this video. Let us continue our discussion. We were going on a sequence. First we discussed about reactions of alkanes, then we discussed about reactions of alkenes. Now in this video we want to talk about reactions of alcohols. Very important family in organic chemistry. It is a very diverse group. It has a lot of applications and play a very important role in many reactions. What alcohols can do, one of the most important reactions alcohol can also do is the complete combustion reaction. As we discussed before, combustion can be of two types, complete and incomplete. If we talk about complete combustion of alcohols, take any alcohol, they all react the same. Family in organic chemistry, they all react the same. Let's suppose we take ethanol. We have C2H5OH. I told you before that combustion always occurs in the presence of oxygen, and what's the product? You always get carbon dioxide, you get water, and you get a lot of energy. This is like 3O2, this is like 2, and this is 3. Balancing is very important. If you don't know how to balance, you must know. There are some videos available in the playlist. You can check about that. So this is one combustion of alcohol. Now we want to talk about oxidation. For oxidation of alcohol, you need to understand first, like if it's a primary alcohol or it's a secondary alcohol. It must be understood, because primary alcohol will react differently, secondary alcohol will react differently. And how to differentiate it, we already have done this video before, like the classification of organic compounds, in which we have discussed about alcohols also. So let's talk about primary alcohol first. Oxidation of primary alcohol. Keep this thing in mind. The beauty of organic chemistry is that you understand the concept, they all react the same. When we talk about primary alcohols, so obviously all of them will react the same way. Okay, this primary alcohol oxidation, it's a two-step process. What's the steps? First, you take an alcohol, you start the oxidation, it will become an aldehyde, and that aldehyde with further oxidation, if continues, it becomes a carboxylic acid. If you remember this general reaction, you can have any alcohol, you will get the respective aldehyde and respective carboxylic acid. What are the agents, or you can say a catalyst, better to say oxidizing agents? Two famous ones: potassium dichromate, it's K2Cr2O7, or you can also use potassium manganate, which is like KMnO4. These are the oxidizing agents which are used. One of them is fine, you just memorize them, KMnO4 or K2Cr2O7. So for example, you have ethanol, you do the oxidation, it will become ethanol, because the respective aldehyde is ethanol and respective carboxylic acid will be ethanoic acid. Similarly, if you have, for example, butanol, should be primary alcohol, butanol will become butanol and it will be butanoic acid. Simple as that. You just want to remember the functional groups and the names, you are done. For example, let's draw the structure of butanol. It's two carbons, so carbon, carbon, there is a OH, it's a primary alcohol. So let's take the hydrogens here. And this is 4, 5, 6, this is 7, and this is 8. You start the oxidation. Oxidizing agents are potassium dichromate or potassium manganate, as we discussed before. It will become first ethanol. So we have carbon, what's the functional group? Double bond with O, single bond with H, right? And just make two carbons, so one more, and remaining are all hydrogens. 3 hydrogens will be there. It can go one step further, which will be carboxylic acid. We know about carboxylic acid, double bond with O, single bond with OH. Sorry, one more carbon, carbon, and this is hydrogen. So this is ethanoic acid. Same way, just change the number of carbons. From 2 to 4 it becomes butanol. From 2 to 4 carbons, butanol. If it's 6 carbon, for example, same reaction can go. Like if it's hexanol, primary alcohol, first will become aldehyde and then it will become carboxylic acid. You may ask a question like, is it possible to take out hexanol and finish? Yes, it is possible. You can recover. You want to stop at aldehyde. Yes, you can do that. But you can do with the process of distillation. If you do distillation here, like it will go up, the temperature is high, you can prevent further oxidation and you can stop the reaction here. Okay, how can you do that? Because hexanol, or you can say like the aldehydes, they do have lower boiling point as compared to carboxylic acids. Their boiling points is lower as compared to carboxylic acid. So with the help of difference in intermolecular forces and stuff, you can take out the aldehyde. But if you want to continue the reaction, what you can do, your desired product is not aldehyde, your product is carboxylic acid, so you can continue further. Like you can use a technique here which is called refluxing. What is refluxing? It's like a technique which involves cyclic evaporation and condensation. Like the thing, aldehyde will try to leave the chamber, you further condense it, so instead of leaving the chamber it goes back for further oxidation. Like you have like uh, evaporation and condensation at the same time, so it prevents the mixture to leave the apparatus. Like it will try to leave, aldehyde wants to leave, but you have some apparatus which is doing condensation, so it goes back in the material. This technique is called refluxing. So you can continue, you can take both the products out. If you want, you can take aldehyde also, and you can take carboxylic acid also. This is the reaction for primary alcohol. What if it's not a primary alcohol, it's a secondary alcohol? In case of secondary alcohol, it's a one step process. For example, you have propane 2-ol, you have a carbon, carbon, carbon. It's a secondary alcohol, so functional group is here, because the carbon which is attached to the functional group should have 2 more carbons, and these are all hydrogens. So this is propane 2-ol. I hope you know how to draw it. If you have issues, please refer to the videos. Propane 2-ol, it directly becomes a ketone. Secondary alcohol directly becomes a ketone. Directly a ketone. There is no further hydrogen, so it's no further oxidation possible. So it directly becomes a ketone, and the story is over. You can fill the hydrogens here. This is ketone. So primary alcohol is 2-step. First it becomes an aldehyde, then it becomes a carboxylic acid. Secondary alcohol directly becomes a ketone. Okay, then I want to discuss one more. Let us do it here in this video and finish our discussion of this series, which I wanted to talk about organic chemistry. We want to talk about a very important reaction which is called esterification. What is this reaction? This reaction is about when you have a carboxylic acid, this carboxylic acid reacts with alcohol. When these two react, what you get an ester. This reaction is called esterification reaction. Okay, they have a lot of usage. They are used as explosives, medication purposes. Okay, so it's also a reversible process. So carboxylic acid reacts with alcohol, you get ester. And what's the catalyst used? Catalyst used is concentrated sulfuric acid. This reaction is also an example of homogeneous catalysis. If you have studied the chapter of, I think, rate of reaction, you may have studied about homogeneous catalysis. That is that the reactants and the catalyst are in the same phase. This is a liquid, this is also a liquid, this is also a liquid, so this is also homogeneous catalysis. This reaction is called esterification. You take one carboxylic acid, you take one alcohol, they react in the presence of sulfuric acid, and you get a ester. Let's derive an equation. Let's take any alcohol. Take any alcohol you like. Let's say we have propanoic acid. Sorry, take alcohol and acid. So let's take propanoic acid first. CH3, CH2, COOH. And let's take an alcohol. As we said, this is a reaction between carboxylic acid and alcohol. Let's take an alcohol, to make it easy, make a alcohol methanol, CH3OH. I want to see the reaction. If you look at the mechanism, it's a very simple reaction. What happens? Indeed, you see very closely, this hydrogen Okay, you remove and take the alkyl radical from here, not the OH. Keep the OH away. This OH and this hydrogen, they combine and you get water. Always. You get always a water here. Okay, and what happens instead of this hydrogen, who takes the place? The alkyl radical of alcohol. So what do you get? Swap them and you take that. No rocket science. CH3, CH2, you have C double O, remove the hydrogen, put CH3. Done. This is ester. Just swap. Swap the H of the carboxylic acid with the methyl part of the alcohol. Now the question is how to name it. You name the kester, you have two parts. If you look at the functional group, you will see that one part is called aryl part and one part is called O8 part. In ester always have two parts, aryl part and O8 part. Okay, going back to here, or I should write here, if I show you how to write it, I need to write an equation here to make it more proper. Let's say I have a propanoic acid, which I just draw. To make it easy, I want to write it. Propanoic acid plus methanol will give me my respective ester. Now I want to name this ester. Target is to name it. Always remember the aryl part and the O8 part, two parts. This aryl part will always comes from the alcohol, and this O8 part will come from the acid. Now this is methanol, so methanol will become methyl. This is meth, so methyl, and O8 will be from the acid, so methyl propanoate. Methyl propanoate. This will be the name of the ester which we have it here. Where is the ester? This one. This is methyl propanoate. How I can read it? This is methyl, and this is 3 carbon, so propanoate. Methyl propanoate. Let's take one more example to further clarify. Let's take any other alcohol. Let's say we have butanoic acid which reacts with ethanol. We have methanoic acid which reacts with ethanol. What will be the respective ester? It will be ethanol will give the ethyl part, ethyl, and butanoic acid will give the O8 part, so ethyl butanoate. Ethyl butanoate. If you want to draw it, how can you do? It's 4 carbon, same thing, CH3, CH2, CH2, C double OH. You can put this in bracket also, like CH2 twice, same thing. You have here CH3, CH2OH, right? CH3CO2H. So what happens? This hydrogen and this OH, they combine and they give you water. And what you do in place of this hydrogen, just put out the alkyl part. So you have CH3, CH2, CH2, C double O, and here you just put CH3, CH2, like that. You can finish. Okay, it can be like CH2, CH3, doesn't make any difference when you are writing. Yes, you can write CH2, CH3 also. Yes, that's all I wanted to discuss in organic chemistry with you. I hope you liked it, you understood it. Thank you so much for your time. Have a good day.